In this video, I'll be talking to you about annuities, methods of saving, and investments. So it says here in section 8.4, investors like Grandma and Grandpa invested a lump sum for each investment. When investing for the future, most people don't have that kind of money to invest up front. Most people invest some amount monthly or annually instead. This kind of investment is called an annuity. An annuity is a sequence of equal payments made at equal time periods. Usually it's once a month, because that's when people tend to get paid, or once a year. At the end of the year, people will decide how much they want to put away in some kind of an annuity. The value of an annuity is the sum of all deposits plus all interest paid. All right, so in this section here, it says the value of an annuity where the interest is compounded once a year. So this is the type of investor that looks at their taxes at the end of the year and a lot of times will decide how much they want to invest, sometimes to help reduce their tax burden for that year. So it says here, if P is the deposit made at the end of each year for an annuity, so notice P is not a lump sum, it's the deposit made at the end of each year that pays an annual interest rate R in decimal form, compounded once a year. The value A of the annuity after T years is, and we have this formula here. So in number one, we'll apply the formula. To save for retirement, you decide to deposit $1,000 into an IRA at the end of each year for the next 30 years. If you can count on an interest rate of 10% per year, yeah, that's pretty high, but we'll go with it. Compounded annually, how much will you have from the IRA after 30 years? All right, so here's our formula. So P, which is the amount we're depositing each year, is 1,000. And then it'll be parentheses 1 plus the interest rate, which we'll write as 0.10, to the T power, well, the time is 30 years here, minus 1, and that's all over R, which is 0.10. And so you should be able to plug that into your calculator, and you get $164,494. So in 30 years, that's not bad. I would say, though, you're probably going to want to have more than that to retire in 30 years from now. You know, your money's not going to go as far. So $1,000 at the end of each year is probably not enough. But let's go ahead and look at this in more detail. We're supposed to find the interest in part B here. So the interest, well, let's see, how much did we pay into this thing? Well, so we'll call this my contribution. We paid $1,000 at the end of each year, so that's 30 times. And so we spent $30,000, or our investment into this was $30,000. So if you take how much the investment is worth after 30 years, the future value we call it, and subtract the $30,000 that we contributed, then you can see we were paid $134,494 in interest, which is a chunk of change. Is that enough to retire on? Probably not, but hey, it's a start. It's something. All right, let's move on to the next page. So here it says the value of an annuity where interest is compounded n times per year. So generally speaking, we're going to mostly we're going to limit ourselves here to things that are paid monthly or annually, which we just did. So in this case, you're making your payments monthly. It says here at the end of each compounding period, but because most people get paid monthly, we're going to be using n equals 12. I think there might be one problem where it's not 12, but usually it's 12. And the interest is compounded monthly or 12 times per year. All right, so generally speaking, that's how this is going to work. So let's look at number 2. Now, I do want to mention, if you look at the formula, there's really nothing new here. We know what R is, we know what N is, we know what T is. And just remember, P is not some lump sum, it's the amount that we're paying per month as we try to build up this savings. All right, so let's look at number 2. At age 25, to save for retirement, you decide to deposit $200 into an IRA at the end of each month at an interest rate of 7.5% per year, compounded monthly. So again, not the most realistic interest rate, but we're going to go with this. In A, it says, how much will you have from the IRA when you retire at age 65? Notice also that because it's each month, our N is 12, and also you also can see that we're compounding the interest each month. All right, so let's go ahead. So we're using this new formula. It looks like this. And so our payment amount is $200, and it's 1 plus our interest rate, which is 0.075, over N, which we said here is 12, to the NT power, that would be 12 times. Now it's from age 25 until you retire at 65, so that's 40 years. So 12 times 40 minus 1 all over 0.075 divided by 12. Our interest rate written as a decimal divided by N. All right, so when you plug this into your calculator, you should get $604,764, rounding to the nearest dollar. All right, so here it says find the interest. So you might see if you can figure that out and then watch the video. All right, so find the interest. I need to figure out how much I contributed. Well, it's $200, 12 times a year. For how many years? 40 years. And so my contributions are pretty significant, $96,000 over those 40 years. However, the value of this thing is $604,764, which means there's a lot of interest here. So if you take the $604,764 and you subtract our contribution of $96,000, you can see the interest earned is $508,764. Now, again, I don't know, in 40 years, is $604,764 going to be enough to retire on? It may not be, but at the very least, it's a good starting point. You know, if you owned your own house and, your expenses were pretty minimal, then, and especially if you were also getting some Social Security or some other stuff for retirement, then you'd probably be in pretty good shape. All right, let's move on. So planning for the future with an annuity. So if you think what we did last time with lump sums, we learned how to find compound interest, and then we also learned how to have a savings goal and use a formula for future value. And so we're doing the same kind of thing here. Notice in this formula, we're actually solving for P, which is our monthly payment, or it's going to end up being our monthly payment. And basically A is some kind of financial goal that we have, a certain amount of money we want to have in a certain number of years. So it says here the deposit P that must be made at the end of each compounding period into an annuity that pays an annual interest rate R in decimal form, compounded N times per year, in order to achieve a value of $80 after T years is, and you've got this kind of complicated looking formula. So number 3, suppose that once you complete your college education and begin working, you would like to save $20,000 over 5 years to use as a down payment for a home. In fact, that's the hardest part of buying a home, is coming up with the down payment for most people. You anticipate making regular end-of-month deposits in an annuity that pays 6% compounded monthly. So each month we're making payments, and the interest is being compounded monthly. So you can see that n is 12 here. So how much should you deposit each month if you want to have that $20,000 in 5 years? So if you think back to what we did previously, we wanted to take some kind of lump sum and invest that and get $20,000 in 5 years. But again, most people don't have that kind of money to just put a lump sum down and let it sit in the bank for 5 years. So what we're doing here is we're actually doing this by making monthly payments into this account. All right, so how much should you deposit each month? So let's go ahead and write down the formula. And so we have P is equal to A times R over N, all over the quantity 1 plus R over N to the NT power minus 1. All right, so let's go ahead and plug in our numbers. So A is 20,000. Again, that's our goal, our financial goal, times our interest rate over N, so 0.06 over 12. In the denominator, we have parenthesis, 1 plus 0.06 over 12 to the NT power. Well, N here is 12 and T is 5. And so 12 times 5, and then don't forget minus 1 into parentheses. So when you plug that into your calculator, you should get $287. And so that's how much you're going to have to put away each month if you want to have $20,000 in 5 years. Now it says on part B, how much of the $20,000 comes, or down payment, comes from deposits and how much comes from interest? Well, I'm paying $287, so this is our contribution here. $287, 12 times a year for 5 years. And so that would be $17,220. Now, we know that this thing will be worth $20,000 in 5 years, so if we subtract the two numbers, we get $2,780. And so basically, that's what we're earning in interest. It's not a great number, but it definitely will help. It's money we don't have to take out of our own current pocket. All right, so let's move on to the next slide. Oh, actually, this is the last slide. I want to make a couple of comments here, things that you'll run into in the homework. So number one, people who buy a bond are lending money to the company or the government institution from which they buy the bond. So for example, our school district, every once in a while there'll be some kind of a bond proposal, and the voters have to, approve of it, and then our schools will build new facilities or update facilities. They use the money for a lot of different things, which is all laid out in the bond. And so people are basically, people that invest are basically lending money to the district. And cities do this all the time, and there's a number of different types of entities that do bonds. And then the other comment I want to make is people who buy stocks are investing in a company. And in fact, they're buying shares in the company. And what happens is normally, and honestly, I don't know a whole lot about stocks. I don't do a whole lot of investing directly into stocks. But you basically buy shares, and once a year, at the end of the year or whenever their business year is, you may get dividends where they pay you some money because they had a good year, whatever. But eventually when you sell your stock and it's worth more than what you paid for it, that's when you make money off it as well. And hopefully the stock's gone up a lot, so you can make some good money out of that. All right, so that's it for this lesson, and have a great day.